twins dating twins for the product rule, right? This whole product rule that we're trying to come up with. Now, would you say, like, again, these are non identical twins. What are those things called? Fraternal twins? Paternal twins, fraternal, one of those two things. Okay, would you say that this guy right here is the maybe the derivative of that one, or maybe vice versa? I don't know. Which one do you think? And then likewise, like these girls that are right here that are identical twins, would you say that this one is the derivative of that one, or maybe vice versa? Okay, keep that in mind here. And what we're trying to do is we're trying to find the derivative of a product of two functions. So I'm just going to go ahead and name it h of x for the product of these two functions. Just, for the sake of preserving the alphabet, h comes before f and g, of course. All right, then. And we want to use the limit definition of the derivative to come up with what we're going to call the product rule. Okay, so since this already has an h in it, I don't want to use the little h in the limit definition. Here, take a look. All right, so if I come over here, and if I were to take the derivative as the limit definition, it would look like the limit as h goes to 0. Do you see how that's confusing? H and this thing is called an h. Does that mean that we're taking the y going to 0? No, we don't want that to happen. So I'll make that a delta x. And then instead of having, let's say, h of x plus h there, again, that doesn't make much sense and is totally confusing. We'll put a delta x minus h of x, all of this over delta x. And I know what you're thinking. Maybe we should have just renamed the function, maybe p for product or something. I mean, sure, that would have made sense, but I didn't do it. Anyway, so you're going to need to write some small, maybe turn your paper landscape in order to get all of this crammed in here. So I'm going to write as small as I can, maybe even zoom in a little bit. All right, so h prime of x is equal to the limit. Delta x goes to 0. And then we're going to have to take this x plus delta x and then plug again for each of these x's right here. I do believe we can handle that. F of x plus delta x times g of x plus delta x minus the original function, which is the product, all of this over delta x. Okay, so what would happen if we plugged in 0 for our delta x? Of course, those two things would be 0. I'd have f of x times g of x minus another f of x times g of x. That'd be 0 over 0. Indeterminate form, of course. So usually when we are fixing an indeterminate form, it's a case-by-case basis. We don't know what to do until, like, we look at the functions. Do we have to multiply by a conjugate? Do we have to factor? Do we have to expand things out and cancel out stuff? Like, we don't know what to do because these functions here are completely generic. They're supposed to represent every single possible case. So, you know how we can multiply by 1 and not change the function? We usually call it a fancy one, right? So we can rearrange things. Well, we can do the same thing, or a similar thing, by adding a fancy 0. So I can add anything I want to this quotient as long as I subtract it back out, and then it doesn't affect anything. So the fancy one that I am going to add and subtract here is going to be f of x plus delta x times g of x. Why is that? Well, we'll see. Okay, who came up with it? I want to say it's Leibniz, but don't quote me on that. It's not a historical record citation needed. All right, so in order to do this, I'm going to have to extend out this little fraction bar here. Hopefully that's long enough. So I can add and subtract my fancy 0. And you know what I can do? I can just copy and paste this one. So let's copy and let's paste. There we go. Put that one right there. And then let's also subtract one. I just added it. I also need to subtract it. No, this one there. Paste again. Yep. Perfect. Okay. Now, what I'm going to do is I'm going to rearrange all of these things up top. I'm going to group these things. So specifically, here, let's move this down so I can write on it a little bit. That should be enough space. Okay, maybe this green crayon here. I am going to pair up a positive one with a negative, right? These things are identical to each other. It's just that one is negative and one's positive. And notice that this one's negative and then this one's positive. I'm going to pair up this negative with that positive and this negative with that positive. Why am I doing that? Because we're talking about slope here, and we have a change in y and a change in x. Oh, it's looking like a foil thing. It's looking like a rainbow, sort of. If these were the colors that were in a rainbow. All right, let's rearrange stuff. The thing that takes the longest on this is just like rewriting these things over and over again. All right, so I'm going to take the first one, f of x plus delta x times g of x plus delta x. Pair it up with the negative one, which is a minus f of x plus delta x times g of x. All right, and then I'm going to do the same thing with the two that are in the middle, but I want this positive and positive one, and then minus this one. So plus f of x plus delta x minus f of x times g of x. And again, the reason why I did that is because I'm thinking of slope, and it's a change in y over a change in x. Hey, look, change in x. Anyway, so let's, what else can I do? Oh, it looks like if I just look at, say, this first set here, notice that they have this f of x plus g of x in common. I'm going to take this, and this I'm going to factor that part out, right? And then the second term, oh, look at that. Looks like I missed something. Here, let me move this out. This should have been f of x times g of x, and I just totally forgot it. Okay, there we go. You could probably do the same thing with your pencil and eraser. All right. I'm going to factor out the g of x that those two have in common. And let's just see where that takes us. Bring this limit notation down, super important. I'm going to factor out this f of x plus delta x from this first set and have a g of x plus delta x minus a g of x. This thing looks kind of familiar. A little bit. Plus, and then we wanted to factor out a g of x from the second one. F of x, plus delta x and minus f of x. All of this over delta x. There we go. Why did I do that? Well, take a look. Does this thing look familiar? Doesn't this thing look familiar? What if I were to break this up as two separate fractions? Go with it here. So make this two different fractions here. Put that one with a delta x and this one with a delta x. Wait, is it clear enough for you? Here, let me make it even more clear. So limit delta x goes to 0 of f of x plus delta x. And then just this product here. I pulled this one, separated this thing out from the fraction. And this is just for clarity, just so that it's obvious. Over delta x. Okay, and then I'm going to do the same thing with the second one. I'm going to pull this g of x away from that fraction. Did it again. Didn't even close this one. Okay. I did that because if you take a look about this, what does this look like? If I were to take the limit as delta x goes to 0, isn't that the definition of something? Isn't that the definition of f prime of x? It sure is. This is f prime of x, okay? And then I'm going to do the exact same thing over here. Let's see, this one's going to get green. I'm going to take that one. And if I take the limit as delta x goes to 0, isn't that the derivative of g of x? Right? It's that difference quotient up there. This is g prime of x. And now let's just see what the rest of this is all about. Okay, so if I take the limit as delta x goes to 0 of f of x plus delta x, this delta x here is going to 0, and this is going to approach just f of x times that g of x. Bring down this plus sign, and then one last time, this delta x does not affect this in here at all because there's no delta x to change, so it's just a g of x. Bring that down. And there we have it. This is the derivative of a product. This is the product rule, but I usually like to rearrange it just a little bit here. So here's how I like to write it. Now this is addition and multiplication, which is completely associative and commutative, so I can like rearrange this a little bit. I like to put this one first and switch the order of those two things. So I'm going to write this as f prime of x times g of x plus, and then I'll write the other one in the same exact order that it appears. So f of x times g prime of x. Why'd I do that? Because I think it's easier to both remember and to extend out to as many products as we want to. So it's the derivative of the first one times the second one plus the first one times the derivative of the second one. And like I said, you could string together as many of those as you want to using the same exact pattern. The derivative of the first one times the second one plus the first one times the derivative of the second one. So remember that picture about the twins dating the twins? Here, let's go back to it. So I'm thinking that this one is the derivative of the first one times the second, and the first one times the derivative of the second one. Now those are interchangeable, of course, because maybe you think that this guy is the derivative. Look with his Zoolander face here, that this guy is the derivative of that one, and she is the derivative of this one. Like I said, it's interchangeable. It's, you know, up to personal taste.